This is a 2.1 amp USB charger socket from ScrewFix, and it's failed. The sockets themselves work perfectly fine. After all, well, they're just a straight pass through to the mains. The USB charger, however, has stopped working. Plug in a device, it goes, "I'm charging!" "Oh, no, I'm not." Unplug it, plug it in, "I'm charging!" "Oh, no, I'm not." So there's obviously something fundamentally wrong with this charger in this socket. Incidentally, I've just replaced the socket, and the new versions, I've noticed, are now 3.1 amp, not 2.1 amp, so they've obviously had a bit of an upgrade. So, let's rip it apart, see what's inside. That one should do. Right, I've got a feeling the earth strap across the back here is going to pose a slight problem, because it looks like it's riveted here, and of course the screw mounting holes at the side are also rivets. So given that this has already failed, and I'm not likely to trust it once I've repaired it, if I do even bother to repair it, I think we can safely sacrifice this completely and just destroy it, just in the interest to see what went wrong with it. Yeah, that's not going anywhere whilst that strap is in place. Let's have a look. Right, can lever this out enough. Oh, that's tough. Oh, there we go. That's now rendered the socket illegal because you can't ground it properly. Right, inside, there we go. Right, let's just make sure that's discharged. Yep, and that one. It should be, since it's... Has it got kite mark on here anywhere? It's CE approved, British standards, yes. So yes, it should be a fairly high quality supply. Oh, that's nice. Proper charge controller chips on the socket, so you can use different types of devices on them for the different charge standards. When charging a mobile device through USB, the two data lines are put in different states depending on how much charge current the charger can provide. And different phone manufacturers have different ways of doing it. There is no standard, or there wasn't a standard. So putting specific voltages on the data lines told the phone different things. Like you can charge 1 amp or 2 amp or half an amp, etc. Now there's a standard that if the two data lines are tied together, then it's what's called a DCP, a downstream charging point, or a dedicated charging point, depending on whether there's actually data or not. But it's a downstream charging point, which means that it's allowed to draw up to 2 amps. But because there wasn't any standard, you can't just set it to one thing and expect everything to work. So proper chargers have these special dedicated charge controller chips, which actually enumerate the device you're plugging in and go, ah, this is an Apple device. This expects the data lines to be in such and such a state for it to be a 2 amp charger. So the posh ones, which this obviously is, have these chips. See if I can get a number for that chip. Probably not on such a small chip. I can see a 3002D. I shall have to look that up, and if I can find a data sheet I'll slap it over the top. Sorry, I just nudged the phone there. So all the charging control is all done on this nice little board here, so that could be a very useful board to hold on to. I'm going to keep that. That's not going to get dismantled, because that could be a nice little dual port charger to build into something. Just provide it with 5 volts and the board does the rest. Brilliant. Right, the power supply. This is probably where it's gone wrong, and I can see something already that I don't much like. So, what do we have on here? It's a fairly typical power supply. We have the power coming in, we've got a little bridge rectifier, smoothing, a little bit of filtering, a controller chip buried down in there, which is touching the transformer, which might actually be doing a bit of heat sinking on it. Possibly have a built-in temperature sensor. Interesting. So Class X capacitor going across the 2 windings. Output filtering, not bad. There's probably components on the reverse as well, because there's very little on here. This is a plastic housing, by the way, not metal. I'll just pop that out. It's got a sticky pad on the back, which isn't very sticky. Oh yes. There's our actual bridge rectifier on the reverse. Good clearance on that. See the gap, giving good clearance between the mains input on the AC side and the DC output. Nice clearance there, and across the transformer there's a good gap with no tracks. That's good design. No slotting or anything on there. It's not necessary, but it's nice to have a bit of slotting just to increase the isolation a little bit more, but there's a pretty decent gap there regardless. So what do we have? We've got the input rectifier, which then goes into a good big smoothing capacitor, 10 microfarad 400 volts, a little bit of filtering with an inductor, not a common mode choke unfortunately, just a little bit of filtering. And does that then go into... Yeah, it looks like that's then another capacitor across it. So that's basically forming a pi filter of capacitor, inductor, capacitor. That's the same size capacitor again, 10 microfarad, 400 volt. That's the little charge controller chip. I doubt I can get a number on that, it's way too small. Where's my magnifier? There it is. And I'm seeing... there is something on it. It's looks like a 66YK. Completely meaningless. The problem with these tiny chips is that there's no standard way of numbering. There's nothing. There basically isn't room to put a full number on. So you tend to get cryptic codes which only mean anything if you already know what the chip is. Because the code has to be looked up in the datasheet for the chip to see what the code means. And unless you know what the chip is, you can't have the datasheet. If you haven't got the datasheet, you can't look up the code. If you can't look up the code, you don't know what the code means. You're screwed, basically. So there's little chance of finding out what that chip is. There's a good lot of passives. Diode there for switching. Another diode. There's no feedback from output to input. So it's not a stabilised 5 volt output on this. It uses what's called primary side feedback, I think they call it. If you've noticed, the pins for the primary side of the transformer, there are 4 pins. You've got 2 pins for the primary, and then there's 2 more pins, which is the feedback winding. So the primary induces current into both the secondary and into the feedback. And as long as you've got the ratios correct, the feedback from the feedback winding should give you a reasonable estimation of what the output current will be, output voltage will be. In a big, like an ATX power supply for your computer or whatever, there will be an opto-isolator coupling the output to the input. And even in smaller ones as well, you get them. so that the input stage knows exactly what the output voltage is and can regulate it much more precisely. So you get a rough 5 volts, but for USB charging, that's really all you need, is only a rough 5 volts, because I think the official voltage range for a USB port is 4.75 up to 5.25 volts. Anything in that range is okay. So a rough 5 volts coming out would be okay. Again, we've got another little pi filter here. They do like their pi filters in this design. Capacitor, inductor, capacitor. We've got main rectifying diode. It's just as with most of these designs, they always seem to have a half wave rectifier. It always seems inefficient to me that why not have a full wave rectifier? It's quite simple why. With a full wave rectifier, you tend to get double the voltage drop. So just one single diode, a good bit of filtering, and you get a 5 volt output. No idea what's gone wrong with this. There's no venting on the capacitors anywhere. Oh yes, there is. Hello. I don't know if you can see this. If we can hold it sideways, this capacitor here, that is domed. It's vented. That capacitor's blown. That one there you see is nice and flat, but this one here domed nicely there. So that capacitor has gone. That should be an easy replacement. Where are we? What's the voltage? It's a 6.3 volt, 1000 microfarad. I've probably got one in my box somewhere. So that would be an easy replacement if I wanted to use this as a little 5 volt mains power supply in a project. I rather suspect that the reason this has died, although we've got a bit of pinching going on here. You see the output here? I don't know if you can make this out. If I can focus on it. The wires there have been pinched slightly, and the same on here. There's certainly a bit of abrasion and a bit of squashing going on there. That's quite flattened along there. See, there's sort of a flat side to it there where it's been crushed. That really should have been routed round the side there, I think. So that might have contributed to it, but unlikely. More likely, I think because it's only a 2.1 amp supply with 2 sockets on it, that 2.1 amps is split between the 2 sockets, so you can either have a 2 amp device in one socket or 2 1 amp devices in both sockets. And I think that's why they've upgraded it to a 3 amp supply now instead, because if you plug two amp devices in, you're obviously trying to draw 4 amps and it can't. So this has been rather overstretched when it's had two amp devices plugged in. It used to be one iPad and one iPhone at most, but that's now been upgraded to 2 iPads for this specific socket. All the other sockets in the house are generally just one device, one iPad in the kitchen, for instance, when baking, that sort of thing. So yes, I think a 2 amp socket in where this one has ended up being too small. And since you can't get the 2 amp ones now, I think that's probably what's happened. Right, so it should be an easy fix, and I might give that a go and maybe use it in a project. I'm certainly going to be using this in one of my little designs in the future. Quite a nice, useful little board, including its own little JST PK, I think they are, those ones, the little clips. 2mm pitch. Little charge board. Brilliant.